it's something I feel in the dark. I know you needed someone to be holding, someone to finally know your heart. I'll take a shot in the dark. I wanna meet you where you are. I'll take a shot in the dark. I wanna meet you where you are, here in the dark. I'll take a shot in the dark.
на тривогу і 8 ранку в суботу. Сьогодні в нас очікується хакатон, який обіцяли в більш домашній такій атмосфері. Зараз я запрошую Ростислава, може мені виключить світло, щоб його було краще бачити. А поки скажу, що зараз у нас невеличка вступна частина, об 11 буде поділ на групи, і далі ви можете приступати до роботи. Зареєструвалося у нас сьогодні 120 осіб, тому чекаємо, займайте комфортні місця. Можна переставляти стільчики там, як вам краще, як ви відчуваєте. Ростислав, привіт, ти нас чуєш?
Да, я чую вас дуже добре.
Все, супер.
Чуєте?
Вітаю.
Так, а ви мене чуєте?
Так, ми тебе чуємо.
Так, тоді я почну, бо в нас насправді часу дуже небагато. Я радий всіх вітати, дякую, що прийшли. Я розумію, що це дуже зарано в суботу зранку, можливо, хтось вчора там відпочивав десь, да, як це відбувається завжди в п'ятницю ввечері. Дякую всім, що прийшли. Я сподіваюся, що вам сьогодні буде цікаво. Сьогодні дуже насправді цікава тема, як на мене. Я такий дуже великий фанат, я б сказав, Uniswap V4. Я з ними там познайомився ще десь півроку тому. Я потрапив на першу когорту по education, там від Ethereum University. Сьогодні буде від них воркшоп на цю тему. Вони дуже круті, дуже з великою експертизою, дуже класно пояснюють. Я думаю, ви зможете оцінити самі сьогодні. Це дуже така Uniswap V4, я вважаю, що це один з найбільших таких мувів в історії Uniswap. Да? Тобто вони зробили дуже круту штуку, з якою ви сьогодні і познайомитесь. Я почну трішки з того, хто ми, якщо хтось не знає, хто ми і що ми робимо. Ми команда Ethereum Ukraine. Мене звуть Ростислав, я фаундер Ethereum Ukraine. І що ми робимо? Ми робимо мітапи, воркшопи, хакатони в Україні офлайн для розвитку Ethereum екосистеми. Для того, щоб знайомити вас з цією екосистемою, для того, щоб туди закликати більше і більше людей, для того, щоб її розвивати в цілому. Да? Тобто мені вона дуже подобається. Я сподіваюся, що вам також, або якщо ви з нею ще не знайомі, то вона вам сподобається, як тільки ви з нею познайомитесь. Так, сьогодні в нас буде ETH Kyiv Impulse. Це серія міні-хакатонів, яку ми вирішили запустити. Ми хочемо створити культуру builders culture в Україні. Тобто ми хочемо, щоб для людей було дуже фаново прийти і щось побілдити. І типу, щоб це було прикольно, класно. Щоб в нас в Україні з'являлися нові стартапи круті, які виходили б на міжнародний ринок і ставали успішними. Типу, я вважаю, що це було б дуже круто. І я б хотів розвивати цю історію в Україні і допомагати всім, хто хоче в цьому напрямку розвиватись, будувати свої проекти і так далі. Ми намагаємось створити там всі умови для цього. І ми завжди відкриті, до речі, до фідбеку. Якщо у вас є якийсь фідбек, приєднуйтесь до наших чатів. У нас є чат в Телеграмі, в нас є Discord. У нас є багато чого, там є QR-код, який веде на наші соцмережі. Підписуйтесь, щоб нічого не пропустити. І щоб бути в курсі всіх анонсів і так далі. Що буде відбуватися сьогодні? Зараз у нас буде через менше ніж 5 хвилин буде невеличка розмова з одним дуже цікавим спікером. Я думаю, ви оціните. Потім у нас буде воркшоп. Воркшоп почнеться приблизно о 10-й. Е, Потім воркшоп, хто не знає, буде на англійській. Тобто вам, ну, я думаю, це типу must have, якщо ви там збираєтесь щось робити взагалі в Web3 екосистемі, то вам потрібно знати англійську. Це такий стандарт. Потім, після того, як пройде воркшоп, що буде відбуватись далі? Далі буде поділення на команди. Ну, насправді, ви вже можете знайомитись. Там, я думаю, ви вже познайомились, більшість з вас, можливо, один одного знають, та? І це прекрасно. І об'єднуватись в команди, придумувати ідеї. Я думаю, що той, хто йшов, там розумів, що треба вже якась ідея, і вже там щось собі думав і так далі. Я вже поширив там деякі матеріали, де ви можете знайти inspiration, да? Типу, там є дуже багато різних прикладів проєктів з хуками. Я поширив там 3 посилання на різні списки хуків, які зараз вже є, які були розроблені ком'юніті, там розробниками і так далі. Будь ласка, заходьте, дивіться, можливо, ви там знайдете для себе щось цікаве і там хочете там або покращити, або створити щось прикольне своє. Так? Ось, тому, да, welcome. Якщо будуть якісь запитання, в цілому пишіть Discord, будемо спілкуватись там. А потім у вас буде десь приблизно 6 годин там чисто на білд, да, тобто на те, щоб збудувати свої проекти. Я розумію, що це мало, тому що там зазвичай мінімум дається десь 36 годин. Ну, в середньому завжди по-різному, але там 36-48, залежно від формату хакатона. Ну, але навіть 6 годин, я сподіваюся, що ви покажете себе, і в кінці ми подивимося всі ваші проекти. Будемо дуже задоволені результатом, і ви, і ми. Типу, я очікую насправді побачити там велику пророблену роботу від вас. Ми будемо оцінювати проекти за креативом, за креативністю ідей, за той скоп робіт, який був зроблений саме на хакатоні сьогодні. Тому дуже прошу не використовувати свої напрацювання, які у вас є там до цього хакатону. Так, тобто якось так. Ми будемо анонсувати переможців прямо сьогодні. В нас не буде місць, типу, як в традиційному такому розумінні, типу там перше, друге, третє, п'яте, десяте. Що в нас буде? В нас будуть просто фіналісти. Ось, будуть фіналісти, які отримають грошові призи. Ну і, в принципі, все. Я думаю, що я якраз вже 30 хвилин. Зараз мені треба подивитись, що там. Якщо є зараз якісь запитання до мене, задавайте. Я зараз пишу людині. Можете поки вивести, до речі, QR-код, підписуйтесь на наші соцмережі, щоб бути в курсі всього. Так, запитань на мене, я так бачу, немає. Я не відключався, не знаю, чому пишуть, що відключився, я не відключався. Мене чути?
Пробач, тебе просто не було на екрані загальному.
Окей. Так, я тут. Якщо є питання до мене, то задавайте. Можемо поки що поспілкуватись, поки чекаємо.
У когось є запитання? У нас є питання з зали, яким буде наступний воркшоп?
Типу, воркшоп який? Сьогодні, або, типу, в цілому? Після цього хакатону?
Змінилася тема, який буде наступний міні-хакатон, чи є вже ідеї?
Окей. Да, вже є ідеї, вже є підписаний партнер. Наступний. Ну, ми зробимо анонс, але давайте так, просто тому що ви всі прийшли сьогодні на 8:30 зранку, в суботу. Це буде пов'язано з гомоморфним шифруванням. Це там такий доволі популярний проєкт. Це буде проєкт, який дозволяє відправляти encrypted транзакції. Ось, тому, да. Ну, але в нас скоро буде анонс на цю тему, тож просто підписуйтесь і слідкуйте. Окей. Поки ми чекаємо. Так, щоб вам ще розповісти. Да, для того, я не знаю, тут є. Підніміть, будь ласка, руки. Хто тут перший раз у нас на заході або перший раз? Ага, окей, нормально. Цікаво. А підніміть, будь ласка, руки, хто взагалі ніколи нічого не писав на Solidity. Окей. Десь плюс-мінус половина аудиторії. Добре. Добре. А підніміть, будь ласка, руки студенти. Ага. Зрозумів. Окей. Окей. Да, для того, щоб там. Як я вже писав, я не знаю, ви читали чи ні лист. Мали всі отримати лист. Там, в цілому, для того, щоб розробляти щось в Uniswap before hooks, да, вам потрібно знати Solidity. Ну, знати, або там. Ну да, знати, я б сказав, хоча б на якомусь базовому рівні. Ось. Але в цілому ви прийшли для того, щоб навчитися в тому числі, тому я. Ну, тому, типу, це окей. Навіть якщо ви там не працювали з Solidity, це ваш шанс там долучитись до Ethereum екосистеми і щось спробувати там збудувати власноруч. Тому я радий, що ви прийшли. Типу, не соромтесь ставити запитання, не соромтесь намагатись потрапити до якоїсь команди, знайти собі команду і спробувати щось збудувати. Це, як я вже казав, це має бути весело і прекрасно. Тому так, дякую, що прийшли. Поки що спікер не читає, який мав прийти. Так, якщо є ще якісь запитання, до мене задавайте. І якщо ні, тоді, напевно, будемо просто чекати цього спікера, а потім воркшоп. У нас сьогодні ще будуть попи. Там скоро дуже поширимо посилання. Зможете собі змінити пап. Окей. О, давайте так, а підніміть руки ті, хто був на ETH Kyiv Hackathon великому. Окей, десь половина аудиторії. Плюс-мінус. Цікаво. І це все транслюється, да? На нашу пряму трансляцію. Я думаю, що насправді це там до моїх колег. Можна поки що трансляцію зупинити, а як тільки з'явиться спікер, ми її включимо назад.
У нас є запитання з аудиторії.
Давай.
Ростислава, який твій ось
Я нічого не почув. Пропав зв'язок.
улюбленіший
Можна ще
EAP?
Найулюбленіший EIP. Окей, ну в мене їх два наразі. Перший це 7702. Якщо хтось знає, хто це, підніміть руку, хто знає, що таке 7702. Одна людина, окей. І другий це 7683. Хто знає це? Підніміть руку. Ніхто не знає. Окей.
Раз.
Ну, да. Перший, який я сказав. Так, а ну-ка зараз. Так, давайте тоді розкажу про ці API, раз мене запитали. Що тут? Перший EIP 7702, він буде, скоріш за все, в там оновленні Пектра, яке заплановано на перший квартал 25-го року. Взагалі Пектра розділилась на дві частини, хто не знає. Все одно цей EIP 7702 він буде в першій частині. Тобто ми його все ж очікуємо в першому кварталі 25-го року. Що дає цей EIP? Він дає можливість там external owned accounts використовувати як account abstraction гаманець. Да? Типу, в тебе з'являється можливість асайнити код на твою адресу в рамках транзакцій. Тому так, тобто це дає можливість тобі. Це по суті робить можливим використовувати external owned account звичайних гаманців в якості account abstraction гаманців. І це дає можливість бачити транзакції, типу там, що це змінить для фінального користувача. Дуже проста відповідь. Там, наприклад, зникнуть апруби. Тобто от зараз ви заходите кудись там, не знаю, на Uniswap, наприклад, да? Щоб зробити своп. Там першим чином для того, щоб вам зробити своп, вам треба апрувнути там, наприклад, USDT або ефір, ну, наприклад, USDT, якщо ви хочете купити ефір або ще якийсь монету, або мемкоін якийсь. Вам треба зробити апрув, і потім вже ви робите своп. Account Abstraction допоможе, цей EIP 7702 допоможе там прибрати ці степи, тобто ви будете завжди в DeFi, зможете бачити, зможете там все робити з допомогою однієї транзакції. Тобто ви зможете абстрактувати всю складність від там фінального користувача. Це стосовно 7702. 7683 це EIP, який був розроблений сумісно Uniswap сумісно з Across Network. Це EIP для це EIP для кросчейн інтентів. Підніміть руку, хто розуміє, що таке кросчейн інтенти. Окей, супер. Так, це EIP для кросчейн інтентів. Воно вже працює в цілому, да, тут І, типу, завдяки кросчейн інтентам ми зараз з'явився механізм, який дозволяє умовно аля бріджити там асети, наприклад, з L2 на L2 там, в рамках 1 секунди, наприклад. Ви можете самі піти потестувати на крос-нетворк. Працює дуже класно, там мені подобається, я сам користуюсь і так далі. Там воно, типу, інтродюсить нові trust assumptions, да? Тобто там є і деякі трейд-оффи в цьому плані, але воно працює дуже швидко, якісно для невеличких сум, для бріджингу. І це дуже класно. Тобто частково це вирішує проблему фрагментації ліквідності на L2. Я хотів про це поговорити, до речі, з нашим спікером, але він чомусь не заходить. Окей. Можливо, сьогодні він протягом дня з'явиться, і ми все ж таки вийдемо на дзвінок і там поговоримо з ним. Так, на запитання, я думаю, я відповів. Можливо, є ще якісь запитання?
Чек. Розкажи, будь ласка, за хук-ранку, це тут ваш продукт по аналітиці хуків.
Дякую за запитання. Да, продукт там, в принципі, дуже простий. Що ми там робимо? Ми індексуємо за допомогою графів, ми індексуємо пул-менеджер Uniswap V4. Хто знайомий з архітектурою, як збудований Uniswap V4, він збудований таким чином, що там всі пули в одному контракті. Типу, якщо подивитись на Uniswap V3, то там зроблено так, що в тебе кожна нова пара там з фі, да, ну там типу є ID, який складається там з фі, токен B, там ще щось, тік-спейсінг, здається. Ну, і типу, ти завжди деплоїш новий пул, якщо ти створюєш нову пару. Да? В тебе там деплоїться новий смарт-контракт. Uniswap V4 це от всього один контракт на всі пули. Тобто тепер там всі асети будуть зберігатись в одному контракті. Можете спробувати його зламати насправді, якщо це цікаво. Да, є пул-менеджер, і ось через цей пул-менеджер, коли буде створюватись новий пул, там буде генеруватись івент, в якому буде там, ну, прописано деталі цього пула, що типу там новий пул created, да, і там ну, і з таким-то хуком, якщо хук буде, там буде або типу нульовий адрес хука, тобто без хука, або з хуком, і тоді це типу адрес хука, адреса хука. Ось всі ці пули з адресами хуками, які не нульові, ми індексуємо. Потім ми дивимось, ми аналізуємо всі ці пули новостворення. Ми отримуємо постійно по ним дату там, з приводу transaction volume, з приводу додавання ліквідності, да, там, змін якихось в ліквідності, ну і так далі. Плюс ми розуміємо, що там у нас є, наприклад, хук якийсь, хук це смарт-контракт, і ми бачимо там, в яких пулах він там знаходиться. І ми аналізуємо там дані по всім пулам, які асоціюються з цим хуком, да, де цей хук застаплений. І це нам дає можливість розуміти, наприклад, який хук найпопулярніший, який хук має якийсь трекшн, ну і так далі. Да. Тобто ми типу, маємо таку собі аналітичну платформу, на якій ми аналізуємо дуже багато речей. Це Transaction Volume, це TVL, це забув. Success Rate. Success Rate це коли, ну, це ми аналізуємо, скільки транзакцій там failed відносно до total транзакцій. загальної кількості з конкретним хуком. Тобто ви маєте розуміти, що хуки можуть бути також malicious, да? Типу, хтось, якийсь хакер там або зловмисник може створити якийсь не дуже гарний хук і спробувати там викрадати гроші. І ось ми дивимося, якщо там, типу, ну і плюс, або, типу, хук взагалі може бути просто поганий, який там постійно ревертить. Да? І там користувачі просто постійно витрачають гроші на транзакції, і вони всі ревертяться. Ось для цього, типу, є success rate. І ще є gas spending, тобто скільки газу витратили користувачі, використовуючи пули, які зав'язані на цей конкретний хук. У нас є там лідерборди, таблиці і так далі, тобто ви можете зайти там подивитись. Плюс, що ми зробили, ми додали нещодавно AI, який генерує AI-generated description, да, тобто опис дуже простий хуків, яких там верифікований source код. Тобто, якщо ви задеплоїли хук, якщо ви створили пул на Uniswap P4 через пул менеджер, і якщо ви заасайнили на нього хук з верифікованим source кодом на Solidity, на Etherscan, то ми це побачимо, і AI згенерує description та опис на хук-ранку про те, що робить цей хук. Працює прикольно, типу, в нашому розумінні це має впливати на взагалі на adoption хуків. Да? Чому? Тому що там люди швидше зможуть зрозуміти, які хуки там набирають якийсь попит, там, де TVL там збільшується, де Transaction Volume збільшується, да? І що вони роблять. Тобто ти, наприклад, не тільки можеш там побачити аналітику, да? Що там ці хуки там в топі, наприклад, там є топ-10 хуків, а ти ще можеш зайти і одразу побачити, а що він робить. Типу, там, наприклад, хук для лімітних ордерів, да? Типу, там трансформує пул таким чином, що можна ставити лімітні ордери. Ну, як варіант. І ти це одразу бачиш description. І проста людина може зайти і подивитися це. І це прекрасно, я вважаю. Ось, а тому якось так. Так. Ось для
Дякую.
цього екрану. Блін. Не вийшло чомусь у нас. Ну, але я думаю, протягом дня, якщо він, типу, з'явиться, я думаю, що ми зможемо поспілкуватись. Нікуди не відходьте. Е, Це може там статись будь-який момент, насправді. Тому. Тому. Ну, буває. Правильно зробиш. Так. Окей. Тобто, в цілому, я думаю, я більшість речей сказав. Якщо, знову ж таки, якщо є запитання, доєднуйтесь до Discord. Приходьте також на наші наступні хакатони, і дуже хочеться побачити сьогодні якісну та креативну роботу від вас. Все це ми робимо. Все, що ви бачите, ми робимо саме для вас, саме для розвитку Ethereum екосистеми в Україні. Ми будемо продовжувати. Ми тільки почали. Тому приєднуйтесь, будемо намагатися, щоб це було весело. І щоб люди там отримували задоволення. Навіть якщо ви там не виграєте нічого, да, але отримаєте купу досвіду, поспілкуєтесь з людьми, які роблять те саме, що і ви. Я вважаю, що це вже успіх. Типу, як краще провести суботу, аніж в компанії білдерів, там, повчитись чомусь новому, щось збудувати, спробувати власноруч. І вважаю, що кращого за цей досвід нічого немає. Тому, да, ми будемо намагатись там проводити ці міні-хакатони раз на місяць. Як я вже сказав, у нас буде наступний міні-хакатон вже в листопаді. Тобто, ну, просто плюс-мінус там через місяць. Анонс буде незабаром. Ну, якось так. У нас вже насправді через 5 хвилин буде починатись воркшоп. Тому хто хоче там, не знаю, зробити собі каву або чай, або там кудись відійти на 5 хвилин і так далі, і типу сісти, щоб було зручно з ноутбуком і так далі. Будь ласка, робіть це, бо залишилось 5 хвилин до воркшопу. we gathered for ETH Kyiv Impulse mini-hackathon in Kyiv. So we have the main topic today is Uniswap v4 hooks. And Manu is here from Atrium University. The guys are doing like amazing, brilliant job in terms of educational activities around the Uniswap v4 hooks. They're creating a lot of new builders, hook builders. We call them hookers. So around the world, and like they have cohorts, but I think like you can go ahead and introduce yourself and tell about the Atrium more.
Yeah, thank you for the introduction. So, hi guys. I'll see you guys are settling in. Good to be here. My name is Manu. I'm from Ethereum Academy. So we run courses. We teach stuff. We run a program called Uniswap Hook Incubator. Like Rosti Slav was part of the first cohort that we did back in April, and we teach mostly about Uniswap v4 in the UHI program. How to use hooks, different kinds of hooks, what are the possibilities with v4 hooks, and things like that. Rostislav, one of our emphasis, like, could you please record this one?
Yeah, it's recorded, so not a problem. Yeah, I'm like double checking,
Great.
but should be okay. Yeah. Mhm.
Great. Thank you for that. Yeah, so we teach about v4 hooks, all the different kinds of hooks. It's an 8-week program, and it's followed by a hackathon where you get to build hooks yourself. And we also do sponsor bounties. We partner with other protocols like Chainlink, Eigenlayer, Brevis. Yeah, that's basically how the program runs. So happy to be here. Yeah.
I'm super thankful for you that you're here today. Yes, to teach our Ukrainian devs a bit the Uniswap v4. So I think we can jump into the topic right away. So if you are ready, please feel free to start, and I will.
All right, let's do it. Let me share my screen.
Do you have access?
Yeah, I sent you a request right now.
Yeah, I'm not the host. Anatoly, can you please share the?
Okay, yeah, I think I
Share
have.
the. Yeah.
Right.
Okay.
Yeah.
Cool.
Are you guys able to see this?
Me, yes. I don't know, guys.
Okay, great.
So, like, can we get some insights if you guys see this the monitor screen? Maybe raise your hands or something like this. Say something. Okay,
Yes,
cool.
we see.
Yeah.
See.
That's cool.
Amazing. So yeah, this is like a short, brief intro to Uniswap v4. So I don't know if you guys know, Uniswap v4 just went through an audit. It was one of the largest audits in Pantina. Some of you might have already also participated in that. But yeah, the agenda of this kind of like a 1.5 hours workshop is to tell you about like Uniswap v4 in general, but we'll also take like a very short, brief history of Uniswap, how it came to be. And we'll take a look at the v4 and hooks specifically, and we'll try to build like a very simple points hook at the end of the workshop. So if you want to like go through Uniswap's history, Uniswap v1 launched in 2018, and it was like one of the most influential protocols out there. It still is, to be honest. Like I think it's also one of the largest used protocols on Ethereum. But yeah, when V1 launched in 2018, the idea was simple. You wanted to swap some tokens. There was no alternative to do that. You had to use a centralized exchange. But with V1, you could swap Ethereum ETH with any ERC20 of your choice. And it didn't allow like ERC20 to ERC20 swaps. But if you had to, like, for example, swap USDC with the DAI, what you could do is you could actually take USDC, swap it with ETH, and then again swap ETH with DAI. So that's how the V1 architecture generally worked. And then came V2. The obvious flaw was that you couldn't swap to ERC20 tokens directly. So in 2020, we came out with V2. And the general idea was that you could swap any ERC20 with any ERC20. And you didn't have to go through ETH in the middleman. And 2021, we see concentrated liquidity introduced in V3. So concentrated liquidity, we've come to this point, what exactly it means. But basically, it meant that instead of like providing liquidity across the whole price range for a token pair, you could actually choose a particular price point where you want to deposit liquidity. So this allowed like more efficient capital utilization. It generally made the capital allocation and Uniswap more efficient. And then came Uniswap V4. It's about to be launched. The main standout feature of V4 is hooks. But then again, there's also a lot of architectural changes in V4. It's different how it works compared to V3. And we'll also take a look into this going to the slides. So this is like the tweet that came in the beginning in 2018. Like if you see the date, you can see it's November 2018. Hayden, who was leading Uniswap back then, put out a tweet, hey, we're excited to launch Uniswap Exchange. It's a protocol for automated ERC20 tokens on Ethereum. That was like one of the revolutionary points for like protocols in Ethereum in general. And fun fact, like the first version of Uniswap was actually written in Viper instead of Solidity. So like Hayden showed the code that he wrote for Uniswap. We went to Vitalik like at an event, and then he was like, it's very cool. Maybe we should try like writing this whole thing in Viper. It could be more efficient. And then he instead like rewrote that whole thing in Viper, and then he launched the protocol in November 2018. And the idea was simple, like I said, ERC22 ETH swaps. Then came Uniswap V2 a little later in 2020, and again it enabled ERC20 to ERC20 swaps. And another idea behind Uniswap V2 is that the pool worked in a very interesting way. So you must have heard about this, the constant product market maker equation, X under Y equals K. Like it's generally the thing that like people relate Uniswap to the most to. X into Y equals K is basically Uniswap V2, how it works. So if you take a look at this graph, if X were one token and if Y were another token, amounts of tokens of X and amounts of tokens of Y, the graph, the liquidity will never ever reach zero. What I mean by that is that if you were to swap, imagine this is like a price point, and this is another price point, this is another price point. So when you swap, the price changes continuously, right? As the liquidity in the pools change. But because of this equation where X is the amount of tokens in token 1 and Y is the token 2 liquidity, it doesn't matter what kind of swap you did, it'll never reach, there will never be a point where the liquidity of one token reaches zero. It might come to zero, but it'll never reach zero. So that was like one of the very interesting architecture in Uniswap V2, the constant product market maker equation. And then came Uniswap V3. So V3 worked very differently compared to V2. It didn't follow the X into Y equals K constant product market maker equation, but it rather was designed in such a way that it will actually touch the axis, which means that it's possible theoretically for one of the tokens to reach zero liquidity in a pool. But then again, that this is like a very, in the graph it looks like very small, but this like points are like very far away, which means like for token X to reach zero, the A point is like very far away. It probably in practically might never reach that point unless it's like very something like a meme coin where people dump and pump constantly all the time. But for more generally like relatively stable token pairs, it'll lie somewhere like in this region, in the region where it doesn't touch the axis. So that's how V3 curve works. And then again, another main feature of V3 was that you could actually choose where you want to provide liquidity to. So in the case of V2, if you had to like provide liquidity, when you put like, for example, if it's like a ETH to USDC pool, if I put like 1 ETH and like 100 USDC, the pool, the liquidity will be actually spread across the whole curve, which means it doesn't matter what price the token is at right now. My liquidity will be used at all the points across the curves. But in V3, you could actually choose the exact price points between which you want to allocate liquidity to. And this was more useful and like more efficient in capital allocation. For example, if you take a look at like some of the tokens like USDT versus DAI, the prices of that generally revolves around like $1. Generally, it's like 1 USDT is equal to 1 USDC, or like 1 USDC is equal to 1 DAI. So it helps in like token pairs like that, where there is not much actually volatility. So you can provide liquidity, for example, let's say minus 0.98 to 1.2. In that particular price range, you can provide liquidity for these token pairs. So this is like an example of USDC ETH pool. So the bars you see here are actually liquidity provided at different price points. So this current price is 1 ETH is equal to like about 1,700 USDC. So that's this price, and the bars represent the amount of liquidity people have allocated their capital to. So as you see, generally it follows a trend like this, where the liquidity is highest supplied at the price that the token is at, and then people don't supply much liquidity at the other prices, because if you want to make some as a liquidity provider, if you want to make some profits back, you generally want to provide liquidity where the token is currently at. So that's why you see like a huge spike here and then it goes down again. And then comes Uniswap V4. So with V4, let's talk about like why the problems with V3 and why we had like to come up with V4. So in V3, V3 was amazing. You could do a lot of things that you couldn't do before. But V3 had a couple of problems in that if you were to deploy a pool, it'll go to its own separate pool contract. And this was not very efficient in the terms of that if you had to like deploy a token pool, it was very gas intensive. You had to spend a lot of gas. Or even if you were to do a multi-hop swap, where you swap tokens across the different pools, that's also not very gas friendly, because there's a lot of tokens moving around in just like a one single swap. So the gas for that is also very high. So one of the things that V4 focuses on, like reducing this gas cost, and the way it does that is by having like a singleton architecture, where it doesn't matter what pool you deploy, it'll all come under like a single pool manager.sol contract. So if you see at this point where we see V3 ETH to DAI swap, you see like each token pair, ETH to USDC, USDC to DAI, has like its own pool. It lives in its own address, right? But when it comes to like V4, all of the token addresses, they live like inside the pool manager.sol. So the pool manager manages all of the token pairs collectively. So what this means is that in this case, like if you were to swap ETH to DAI, you first have to go through ETH USDC pool, and then you transfer tokens from USDC from this pool to the USDC DAI pool, and then you transfer DAI to the end user. In this case, it doesn't work like that. If you want to swap like across different pools, you just supply ETH, and then DAI magically comes out at the other end. So there's a lot of less of complications of the gas cost that's associated with V4. Yeah, this is like again like what I just talked about. In previous versions, if you had to like swap ETH with DAI, you send ETH to USDC. If there's no ETH DAI pool directly, you have to swap across ETH USDC and then USDC DAI, right? So in previous versions, you swap ETH with USDC, and then USDC is withdrawn from this particular pool, ETH USDC pool, and then sent to USDC DAI pool, and from there, DAI is withdrawn to the USDC from the USDC DAI contract, and then it reaches the end use. In V4, it doesn't work like that. ETH is sent to the pool manager, and pool manager calculates how much USDC output, and pool manager does not directly transfer USDC tokens, but it calculates how much DAI to give against USDC, and then it just supplies that DAI directly back to the user. So there's much less computation, much less gas cost associated with V4, and this is called flash accounting. And there's also another feature called locking mechanism. So to secure this whole thing, V4 uses like a locking mechanism, whereby if you were to do a swap, the pool manager, you have to call like a particular unlock function so that it doesn't interfere with any of the other swaps. So how it works is you generally have a periphery contract which actually calls the swap, and then it goes to the pool manager, where you trigger the unlock function, and it comes back, and you'll generally have like an unlock callback function, which then again will call the main swap function. And now once this pool manager is unlocked, you can do whatever you want to do with it. So you can, for example, swap any tokens. If you want to do a specific thing before and after a swap, you can also do that. That's where the hooks come in. So it interacts, the pool manager interacts with the pool library, and then it interacts with the hook. We'll come to what exactly a hook is later. But this is basically the custom code that you'd be interested in writing. And so this is generally how the flow goes. You interact with the pool manager, it unlocks the pool manager, and then you're free to do whatever you want. And then ultimately it comes back after the swap is done, after all your logic is executed, it comes back, and in the pool manager, you have a thing called balance delta. You have to make sure that the delta of balances, which means that the amount of tokens that have to be transferred between a user and Uniswap is always net zero. So this means that this ensures that at the end of a swap, if balance delta is zero, no tokens have been lost anywhere, right? So the exact amount of ETH that was supposed to come to the pool manager has been taken in, and the exact amount of DAI that was supposed to go out of the pool manager has been gone out. So that's what balance delta does. If it isn't zero, then the transaction just fails, and then it reverts back. So this is a way how V4 works in general. It uses a locking mechanism to do this stuff. And then we come to Uniswap V4 hooks. So I don't know how many of you guys are like into React, but it's kind of similar to how React uses different kinds of hooks. So if you've ever done like a bit of front-end engineering, you'll see that you have like a couple of hooks that you can use. For example, like use effect, use state. So all of those hooks, what they generally do is that they allow you to do some external activity, like within the lifecycle of a page. So that's kind of like similar to how hooks work. So with hooks, what you could do is that you could actually embed your own custom logic in the lifecycle of different kinds of activities in Uniswap. So what do I mean by that? So let's say you have a swap and you have a pool of your own, and you want to do some custom logic. Maybe you want to send some of the tokens that come into the swap to somebody. Someone swaps in that pool. So what you could do is you could write a hook contract that has this custom logic where the pool, the tokens is taken out of the pool in every swap and is sent to like some address. So this custom logic you can implement it with the V4 hooks. So this is kind of generally the architecture of how it works. So when you start a swap, the Uniswap checks if there is like a before swap hook enabled in your contract in your pool, and if there is one, it will actually run that custom before swap hook or before swap code, and then it'll come back and it'll actually execute the actual swap. And then if you have like another hook that happens after the swap, enabled through the after swap flag, then it'll actually execute that hook, and then again come back to the endpoint. So if you see, like you can do a couple of things like before swap. Before this, it was just like start swap, execute swap, and then end swap. That's it. That's how the flow goes. But from V4, you have this kind of like midpoints where you're allowed to like add custom logic to the swap itself. So before swap is a point where you can do something that you want to do before the swap actually happens, and after swap is a place where you can do some custom logic after the swap happens itself, right? So this is what V4 hooks generally enable. You can hook into one of the lifecycle points and do a custom code execution, whatever that may be. And it's not just swaps. Like there are a lot of hooks. There are 14 hooks in total, right? So let me just go through like all of these, what they do. So we have before initialize, we have after initialize. So this executes when you're actually freshly creating a pool. So if you were to use before initialize, you could actually run some code, custom code, before the pool initializes, even like deploys, right? And after initialize is the same, but that when you deploy a pool, it'll actually after it initializes, you can run some custom code. And it's the same with like the rest of the hooks. If you want to do something before someone adds liquidity, you can do that. If you want to do something after someone adds liquidity, you can do that. Same with remove liquidity, after remove liquidity, before swap, after swap, before donate, after donate. So this is kind of like you have the option to like donate some amount of like token. It's not generally used, these two hooks, before donate and after donate, but you still have the option to do that in case you want to, where you can donate some amount of tokens to the Uniswap, I guess. And there are also a couple of things other than these swaps called, so Uniswap have this feature called no-op hooks, where it allows you to actually bypass this execute swap feature. So you can bypass the whole swap, main swap flow in Uniswap if you want to. And to do that, you will use hooks like this, where it's called before swap return delta, after swap return delta. So these hooks actually even allow you to completely bypass the execute main swap and then just like completely run custom logic throughout the flow. So that's what these hooks do. So let's say if you want to change the pool graph. So if you remember, this is how V4 graph also looks like. But if you want to go ahead and you want to do completely something different, you're allowed to do that. For example, imagine you want a graph like this, x into y equals k. You're allowed to do that with the help of no-op hooks, these last 4 hooks. So we won't take a look into these because we're due to time limitation, but we'll take a look into before swap and after swap in this workshop. And the last point before we actually go into the actual coding part where we make a code, I want to talk to you about the hook address format. So how do you know that a particular pool has a hook which has, let's say, before swap enabled? So how do you know that? So for this, Uniswap uses the address of the hook itself to determine if a pool has a particular hook attached with it, for let's say before swap. To do this, let's say this is your address where your hook is deployed to, right? And what you do is you take the binary format of this, 00000, right? And then from the last bit, from this 0th bit, you turn it on, you turn a particular hook on by switching these bits to 1. So what does that even mean? So let's imagine I want to enable after donate hook, right? So if I want to enable after donate hook, what I would do is I would enable this the 5th hook from the last, and if I turn it to 1, then it means that Uniswap recognizes that this hook uses after donate, and it should use that after donate flow whenever somebody donates, right? And it's the same with like before swap, after swap, before initialize, after initialize. So there are bits associated with all of these hooks, all of these 14 hooks. So from the last bit of the address of the hook contract to the 14th bit, you can turn on particular hooks by switching them to 1. And to do this, you'll have to do a bit of address mining. So you'll have to mine a particular address that suits all the requirements of your hook. So if you want to enable before swap and after swap, which means that 1, 2, 3, 4, 5, 6, you'll have to enable the 7th and 8th bits to 1. So you'll have to do a bit of address mining where you ultimately find an address where the 7th and 8th hook is enabled. So it'll be 0, 0, 0, 0, 0, 0, and then 1 and 1, and then again 0, 0, whatever the rest of them may be. So that's how you declare that you want to use a particular kind of hook in your hook contract. And if you're interested in seeing the exact hooks and exact bits, this URL is also suitable for that. I'll drop it in the chat. I'm not sure if you're able to access it, but yeah, I'll show you anyways. So this is the GitHub page for the hooks.sol contract that V4 uses. And if you'll take a look at this section, the first section, you'll see that.
Could you please pause for a moment? We have technical problem. Oh, okay, you could continue.
Okay. Okay, let me know when it's solved.
It's okay.
I think you can continue, right? Yeah.
Okay. So you can see the GitHub page, right?
Yes.
Amazing. So if you take a look at all these hooks, you'll see that it's noted here. So the last bit of the address of the hook, if you switch that to 1, you'll enable after remove liquidity hook. If you want to enable the after add liquidity returns delta hook, you'll enable the last second hook. And if you want to use after donate hook, you'll enable the 0, 1, 2, 3, 4, 5th bit to 1. So that's how you let Uniswap protocol know that your hook uses these kinds of particular hooks in your hook contract. Great. So now we're gonna move to try to build an actual hook.
Could you please, excuse me, could you please pause again?
Yeah. Hello. What time is it for you guys, by the way? Is it like nighttime, morning?
It's
No,
hooks.
it's
actually.
10:30.
Hooks working.
Amazing. I'll be also back in a second. I just want to drink some water. I'll be back in like 2 seconds.
Guys, let us know when we can continue.
Hello. Can you go?
1 second,
Uh,
please. 1 second.
Mhm.
Okay.
Okay, now.
So we can continue.
Yeah, probably we
great.
have a technical problem with streaming when you switch your screen from presentation to.
Oh. Okay. So
But-
you want me to keep my screen share in like one particular window?
But on the like on live translation right now, okay, yes, we see the QR code. Okay. I think
Okay.
you can go ahead. Mhm.
Okay. Let me share my VS Code. I'll also drop this particular link. In the chat. I'm not sure if you're able to access this, but let me drop it anyways. Okay, great. I'm switching my screen to VS Code. Let me know if that causes something, and I'll take a pause.
Right now I can see the presentation. Okay.
Can you see
so
now?
switch on.
Could you please stop sharing screen and start sharing again?
Okay, yeah. Let me do that.
Nothing happens.
Okay. Let me share my screen. Can you see now?
Yeah, it's VS Code.
Okay, great. Better. Okay, so what we're gonna do here, let me actually initialize a Forge Foundry project. Oh. So I'm just making a new Foundry project, and okay. Okay. Let me make a README on like what exactly we plan to do. Okay, so the idea for this hook is simple. We're gonna make a points hook, and the objective of the hook is simple. We have a token pair called ETH to token, where token is a random meme coin deployed using V4, Uniswap V4. And we want to execute a custom functionality using hooks, where whenever someone swaps on the ETH token pool, we want to give them a particular kind of token as a reward for swapping. So let's say when someone swaps ETH, for token, which means they're buying token, but they're buying from this pool by supplying ETH and taking token, we will provide them a points token as a reward. So this is like a meme coin. If you buy my meme coin, I'll give you some points tokens. So that's what we're trying to build. So it's simple, but you'll get the hang of it because it's such a simple idea. So another thing that we want to do is whenever someone adds liquidity, we'll give them a particular percentage as in points token. So let me say for this, we'll give them 20% of the ETH that they supply. And for the if somebody adds liquidity, we'll give them 100% of the ETH amount that they supply. And we're also going to do a referral mechanism where, let's say I refer Rostislav. Rostik will get some extra points because I referred him and he's using the referral. And I'll also get some points token because I'm the one who referred this swap. So come up with a referral mechanism whereby someone who is referred to swap a token gets a cut in points token. And let's say the referrer will also get a cut via points token. So the idea is simple. We have a ETH token pool, and we want people to buy the token coin. And to incentivize that, what we'll do is every time somebody buys token by supplying ETH, by swapping with ETH, they'll get a points token. And another way to get points token is to supply liquidity to the pool. And that's also another way to get points token. And then another way to get points token is by referring somebody. So if a person, Alice refers Bob, Bob gets a cut and Alice also gets a cut. So that's how the structure of the hook contract is going to be. So, okay. So let me install Forge. For periphery contracts. Give me 1 second. Oh, I can find the. Give me just 1 moment to find the exact name of the before.
No worries, man. It's okay to wait. So no problem.
Okay. Okay, great. So we're installing V4 Periphery. Maybe we can use this time while it's installing to talk about the different contracts that we have. So Uniswap V4 is divided into periphery contracts, and then we also have core contracts. So if you're a hook developer who produces hooks, you will mainly interfere or utilize periphery contracts. So periphery contracts has functions or like Solidity contracts like base hook, which you can inherit to make your own hook. And the core contract is where the core logic of the Uniswap V4 protocol lies. And okay, so the core logic of Uniswap V4 lies in core contracts, Uniswap V4/core. And generally, we'll only use the periphery contracts for this because it has almost everything that we need to make a hook. And in the backend, it'll actually use the core contracts when we're actually doing a swap or actually adding a liquidity to it. All right, give me a moment while it installs. Maybe I could talk about something else while it installs. Yeah, let's get rid of the counter files that we have. And let's make a points hook contract. Points hook dot sol. So this is where we'll actually make the points hook system. And also another thing is that we want to use the latest version of Solidity for this to work. And I think it's 0.8.26. So this is the version of Solidity that we use for the V4 contracts. It doesn't work on like the ones before that. So yeah, we have to use this. And let me also do the remappings for this. It's taking a bit of time to install this. So I'll do the remappings by switching to git bash. And then I'll do forge remappings to remappings.txt. And you will be able to see all the remappings here. Great. Great. While that installs, let's actually try writing the contract. So for V4 periphery contracts, we have I have a template prepared for this. So because I don't want to spend a lot of the time just like writing import statements. So I have a file prepared where I can just fast forward all the things that you probably already know. So I'll go through this stuff in a while. But the main thing here is the base hook contract that he inherited that comes from the periphery contract like I talked about. So base hook has all the abstract functions for you to make a hook. For example, you have before add liquidity, you have after remove liquidity, all the hooks that we talked about. So if you want to use the hooks, you'll just inherit the base hook contract and you'll just override this virtual functions. So, okay, now I'll also go through this in a second, all of these, like what these do, but we'll also move on. And one more thing about this contract. So the points token that we talked about, that will reward people, will be managed in points hook contract itself. So that's why we are also inheriting an ASD20. So this will be used to manage the points token that will reward people with. So great. Now let's actually type in the constructor. Great. So the constructor will have to pass one parameter to the base hook. So we pass in the pool manager. So every chain has like its own pool manager, and the hook contract needs to be aware of the pool manager address. So when we're deploying this hook, we'll take in the pool manager address, and we'll also take in a name and symbol for the points token that we're going to deploy, right? Great. And now let's actually, I'll show you how the after swap thing works. So to make a boilerplate after swap, you just basically inheriting from the base hook, and then you override it. And let's go to the parameters of after swap, the different kinds of parameters we have. So we have the address. So whenever somebody does a swap and the logic goes through this particular hook, the after swap is supplied with the particular parameters. So that includes the address of the message sender that's actually doing the swap. And we have something called a pool key, which determines like which hook, which pool we're going to deploy to. So let's take a look into like what exactly a pool key is. So a pool in V4 is defined by like mainly 5 things. The token 0, that makes up the first token of the pool. The token 1 that forms the second token, and the fee that you want to associate with the pool, and the tick spacing, basically the space in each tick in the V4 graph, and the hooks. So before this, it used to be like this much only 4 parameters used to identify a pool. But with V4, you also have hooks. So this means that whenever you deploy a new hook, you're actually deploying a new pool with that customized logic. So let's say I have a ETH USDC pool, and I can choose to deploy it with no hook. So that becomes a pool in itself. And then let's say I deploy another USDC ETH pool with a custom hook contract. So that thing becomes a pool in itself with that custom hook contract. So a particular token pair, ETH USDC can have many, okay. A token pair, USDC, a pool, let me try this in a better way. A pool is identified by token 0, which is the ETH token in this case, and it's identified by token 1, which is the USDC token in this case, and then the other parameters is a fee and also a tick spacing. So tick spacing is basically the, if you remember, like we had ticks in this graph. Like if you see the ticks at each point, the spacing between each of these points is called a tick. So that's like the smallest unit of price a token pair can be. So it's used to denote the prices basically. So for example, ETH can be 3,000 USDC 1 second, and can be the next point, it can be 3,001 USDC. So all of this pricing is managed internally via something called ticks, and the spacing between each ticks is managed via this parameter called tick space. We won't go deep into this, but that's basically how the tick spacing works. And the last thing is hooks. So in this case, the points hook that we'll write will be passing this to this parameter. Is the screen share working? Like I can see the screen, but it's I can see you guys showing the presentation, but my screen is not on there. Are you able to see the VS Code? Hello. Should I pause?
I'm here. Yeah, so let me check with the guys there.
Okay.
1 second. In YouTube, I see like Visual Studio Code.
Yeah, I'm on my
So,
Visual Studio Code. You can see that?
Yeah,
Great.
I think all
Amazing.
good. Mhm.
Great. Great. I wanted to talk about another thing. So in the points hook that we're building, there's 2 ways to do it. So the ultimate goal is that we want to give somebody a particular pool tokens when they do a swap or when they add liquidity to it, right? So there's potentially 2 different kinds of hooks that we could use. So for the swap one, we could use before swap, or we could use after swap. And for adding liquidity, we could use before add liquidity, or we could use after add liquidity. So these are the different lifecycle events that we can utilize to do this thing where we want to reward somebody with points, right? Let's take a look at like what we can do, like which of the particular hook we should use for this particular use case. So this is also segue into another topic, different kinds of swaps. So in Uniswap v4, you can do basically 4 types of swaps. So what do I mean by that? So they're categorized into 2 different categories. So there is a case, let's say in the case of ETH USDC, I'm swapping, let's imagine that I'm swapping ETH for USDC. Swapping ETH for USDC. In this case, I can say that I have X amount of ETH that I want to swap. So this is one case. I'm swapping ETH for USDC. I'm taking in USDC. And I know that I have X amount of ETH that I want to swap. Or the other case is that I know that I want to swap ETH for USDC, but I only know the output amount. So I know that Y amount of USDC that I want to get from this swap. So that's like one case, right? And the other case is the exact opposite kind of swap. So here, a swap for USDC for ETH. And here I know that I want to swap X amount of ETH that I want to swap. And I know that I have Y amount of USDC that I want to give to this. So ultimately, there's 4 different hooks, 4 different kinds of swap that you could do in like a potential swap. So if I'm swapping for, these are called, by the way, these are called exact input for output swaps, where I know that I want to swap X amount of tokens to get Y, but I'm not sure how much of Y I would get. Not sure how much amount of Y I would get. So this is exact input for output. So I know that I want to swap X amount of tokens with Y, but I'm not sure how much Y I would get back. And then the other case is that I know I want to get Y amount of tokens, but I'm not sure how much of X I need to swap for this. So this is that case. And this can another category, like it's basically the same thing that we talked about here, right? It's just that you might know at one case how much input tokens you want to give, and in another case, you might know how much output tokens you want to get. So you either know one of these. And then the other category is how much or in like which direction you want to swap. So I can swap X tokens to get Y, or I can swap Y tokens to get X.
1 second, sorry, live stream is, I don't know, it's stuck. One second.
Okay.
Guys, let us
let
know
me-
when you will fix the live stream.
Let me also fix some things here for some reason.
Okay, now it works.
Right.
So whenever you can continue. Whenever
Okay,
you're
great.
ready.
But then were you able to catch the last points that I talked about?
Better, I mean, probably yes, but if you can repeat
Should I
it.
repeat? Okay, okay.
Yeah.
So, okay, I'll say this. So there's two categories of swaps that you could do. One is the kind. One category is the token amount you know. And the other category is the direction of a swap. So this is the first category where I know that I want to swap X amount of tokens to get Y. So this is called exact input for output swaps. So I know the exact input that I want to give into the swap. So I want to swap X amount of tokens to get back Y. And the other one is exact output for input swap. So I know that I want to get Y amount of tokens, but I'm not sure how much of X I should put into the swap to get back this particular amount, Y, right? So that's one of the categories. And the other category is direction of a swap. So I can swap X tokens to get back Y, or I can swap the other way where I swap Y to get back X, right? So ultimately, there's 4 different kinds of categories. So in the case of ETH USDC, I swap for ETH for USDC. Then I'm knowing how much ETH I want to give. And the other category is I know how much USDC I want to get back. And the other 2 categories is that I want to swap the opposite, where I want to give into USDC and get back ETH. In this case also, there are 2 different cases where I know that I want to put in X amount of ETH, and the other case is that I want to get back USDC, particular amount of USDC that I want to get back. So ultimately, there's like 4 different types of swaps that we can do. And for this, if coming back to the original point of deciding between which one to choose, if you want to choose the before hooks or if you want to choose the after hooks, we have to decide between one of these. So it turns out, like in some of these cases, it's better to actually use after swap rather than before swap. Why is that? So when you do a swap, you'll only know the exact output tokens or the exact values of both of the tokens that went in and came out after the swap actually happens. So in this case, where I want to swap like X amount of ETH, but I'm not sure how much of Y I would get back. But after the swap has happened, I would get to know that I got like Y amount of USDC, right? So ultimately, we want to use after swap because after the swap happens is exactly where we know the amounts of both of the tokens, right? So before the swap happens, we only know one of the amounts of tokens that we want to swap. So for this case, we're actually going to use after swap and after add liquidity. So that's why we're going to prefer after swap and after add liquidity. Like I could also show you in the base hook how this is all managed. So if I go to like before swap, you'll see the parameters that I have is the address, which is the sender address, the swapper address, the pool key, the particular pool that I want to swap, the swap params, which is like how much of X token or how much of Y token, either one of those, and then some bytes to pass in like additional data. But if I come to like after swap, I have something called the balance delta. There's like this extra parameter called balance delta. And if I were to look into what exactly a balance delta is, it's basically an int256 variable. It's just a type alias for int256. And what it does is balance delta denotes the exact amount of X and Y tokens that come in or go out in a swap. So let's imagine that I'm swapping 100 ETH for, let's say, or maybe like 1 ETH for 3,000 USDC, right? Before the swap happens, I'm aware that I want to put in like 1 ETH, but it's only after the swap I'll know that it's 3,000 USDC that I'm getting back. I might know that I might get around like 2001 or 2,999 USDC, but the exact pinpoint amount of USDC that I'm getting back, I'll only know after the swap happens. This is because of slippage and a couple of other factors, right? So this exact amount, which is 1 ETH and 3,000 USDC, is denoted using something called balance delta, right? And balance delta is nothing. Balance delta is an int 256 that can be divided into 2 int 128. So how balance delta is managed in Uniswap. So in Uniswap v4, balance delta, the first 128 bits of balance delta is used to denote the amount of token 0. So the first 128 bits of balance delta denotes the amount or the change or delta of token 0, the first token. And the second 128 bits of balance delta denotes the change or delta of token 1, right? So what does this even mean? So in this case, where I'm swapping 1 ETH for 3,000 USDC, right? The balance, the delta of token 0, the first token, is going to be 1 into 10 raised to the power of 18, right? So I'm swapping exactly 1 ETH for this. And the delta of token 1 is going to be, so I'm getting back 3,000 USDC, right? So it'll be 3,000 into 10 to the power of 18. So this is how we know the deltas. Now there's an interesting point. So the balance delta also denotes which direction the tokens are coming in. So from the perspective of a user, he's swapping 1 ETH for 3,000 USDC, which means that the user is giving away ETH from his wallet, right? So in this case, this will be minus into 10 raised to the power of 18, which means that ETH, the token 0, or ETH, is actually leaving his wallet. But in the case of USDC, he's getting back 3,000 USDC, which means it's credited to his wallet, right? So in the case of token 1 or USDC, it's going to be positive 3,000 into 10 raised to the power of 18, which means that he's being credited that particular amount of USDC. Sorry. So that's how we manage the deltas in a swap. So coming back to the base hook, so it's only in the after swap that we get this thing called balance delta, where we get to know the exact amount of token 0 that is going and the exact amount of token 1 that is coming back, right? So that's why we prefer after swap in this use case rather than using before swap. So now let's actually come back and do some of the main coding parts. So we had a lot of theory now. Now let's actually go ahead and continue with the hooks. So let me come back to my template. And we're also using after add liquidity. So we're also using after add liquidity for this. So this is just boilerplate function. So at this point, it doesn't have any logic. We're just overriding it. So we will fill it with logic in some moment. But before that, we want to fill it this contract with some bunch of other helper functions that are going to help the after swap and after add liquidity, right? So there's something called get hook permission. So when you make a hook, you might want to be, you also want to declare the exact hooks you're going to be using. And you do that with the help of get hook permissions. This is also coming from the base hook. So if you go here, you'll see the permissions, get hook permissions function here. So basically, this is used to declare the exact hooks that we'll be using. But then again, like I said, we also use the address bitmap to declare the hooks. So why use address bitmap, where we turn the zeros into ones to denote the exact hooks we'll be using? And then why also use this function to denote the hooks we'll be using? So the reason for that is this function isn't actually used by Uniswap to decide which hooks we'll be using, but this is rather like a helper functions for like other third-party contracts or like off-chain tools to decide like which hooks this particular contract is using. You could actually even lie in this. It doesn't matter because it doesn't affect the logic of any of the actions that hooks will take. But it's just used for like to help out like off-chain tools. So rather than the off-chain tools having to go through the exact bit of the address of the hook, they can just like read through via this function. So in this case, we're using the after swap and after add liquidity functions, right? So we'll declare the after swap as true, and we'll also declare the after add liquidity one as true. So we're using these two functions and we declare this as true and the rest of it is false. So now anybody who's interested in seeing or like calling this function can get back the exact hooks that we're using. It doesn't matter like if you lie in this, if you just say that we're using after donate, because Uniswap won't look at this. Uniswap will only look at the exact address bitmap of the deployed hook contract. It's just to help out other contracts and off-chain tools. Great. Now, okay. Now let's actually add some logic to the referral system. So we want to keep a track of the exact people who are referring. So if you remember, one of the features of the hook that we're building, one of the features of the hook that we're going to build is that we're going to refer somebody. We'll have a referral mechanism where you'll be able to refer swaps to somebody. So if Alice refers Bob for a swap, Bob gets a small percentage cut of the points token. And since Alice is the one who referred Bob, Alice also gets a cut of the token. So for this, we'll be using tracking all these referred people and the referees using this particular variable called referred by. And it's easy. It's basically the referrer mapped to the referee. Referrer is the person who referred. So if I'm referring Rostislav, I'm the referrer. And if Rostislav is the one who is being referred by me, he's the referee, right? And I'm also declaring a points for referral. So this is the exact amount of points token that the referrer will get for referring a new person. So we also declared the exact points for referral that we're going to give out. Great. Now let's move to a bunch of other helper functions. There's like a couple of these, and we'll get into the actual hook, the main after swap and after add liquidity part. So we also need a way to decide who is referring and who is being referred. And to do this, we'll be using the last parameter of hook data. So if you see after the address, the sender address, and after the pool key that denotes a pool, after the swap params that denote the exact amount of input tokens or exact amount of output tokens that's coming out, and after the delta parameter that denotes the exact token A and token B that's coming in, we'll have another parameter called hook data that says that's used for some arbitrary logic that we can use. So hook data is where you are allowed to add in some arbitrary data to execute some custom logic that we use. For example, let's say imagine that you want to use ZK proofs in your hook contract. This is a way where the end user can pass in the ZK proof in this particular field. So the end user is the one who supplies this hook data or the extra bytes to execute a custom logic. So we are going to be using the hook data we are gonna be using the hook data to denote who is the referrer in a particular swap and to denote who is the referee in a swap. So that's what we're going to be using the hook data for. And to actually get this as a bytes format, we're going to be using this helper function where we just pass in a referrer and a referee, and it just returns back the ABI.encode or the bytes version of this, right? So that's what this function is for. You'll see it being called in after swap and after add liquidity, right? So the last helper function that we'll need for this thing to work is a function to actually assign points into this. So let me show you how this one exactly works. So if you remember, there's different kinds of cases where we want to assign points when somebody refers a particular person, right? And to do that, we use the hook data and we use the referee points. So first, the parameter is if the hook data or the referee referrer is not passed, then we can just go ahead and like return this because there's nobody to assign points to. If the hook data is empty. If the hook data is empty, it means there is no referrer or referee. So we can skip assigning points token to people. So that's what this does. So what we're doing here is if we're checking that if the hook data that the swapper or the end customer, end user, the message or sender passed, if the length of that is 0, we'll just return this because there's no actual points to assign people to. But in this case, in the case that it's not actual 0, we'll decode the hook data to get back the referrer and referee, right? So they're using the hook data to encode it, and then we'll use the ABI.decode, where we decode the hook data to get back the referrer and referee. So these are helper functions that we use along the way, and great. And once we have the referrer and the referee, we want to check if the referee is 0. So if the referee, the person being referred by another person, if the referee is empty, then we have nobody to assign points to. So we'll just return from this function. In this case, if the referee, if there is no referee, we have nobody to refer to, which means that nobody is being referred, then we can just return because again, we're using this function to exclusively assign points when somebody is referred. But in this case, if there is no one to assign points to, then we just return the function. Now is the actual case where we'll assign some points. So if the code execution reaches this point, it means that there is a referee. So there is somebody to refer to, right? And what we want to check is that, so remember that we had this variable that calls referred by, where referrer is referring a referee. We want to check if this is a first-time referrer. So if Alice is referring Bob for the first time, what will this variable look like? If address of Alice is referring address of Bob, then referred by variable will look like this. Alice is equal to 0 at the instance because Alice hasn't referred Bob before, right? So you want to check for this case where the referee is empty so that we can know that this is a first-time referral. So in this case, we check if the referred by referee is an address of 0, but the referrer is not a 0 address. it means that this is a first-time referral, right? So we want to mint the referrer, the person who referred some extra additional points, because this is the first time that they're referring this new person. And we do these points. If you remember that we had declared a variable that denotes the exact amount of points that we'll give when somebody refers a new person. So we'll give them 500 tokens for a new referee. So that's what this will do. And if you remember, we converted this contract into an ERC20 token, which means that we're managing the points token via the contract itself, or contract itself. So we just mint them 500 tokens of point token. Great. Now, let's imagine that there's another case where we want to give them 10% token when it's not a new, generally when somebody refers a person, we also want to give them 10% of the total tokens that being transferred, right? For this, we check if the referee is not address of 0, and if it isn't, we just mint them 10% of the tokens. So that's what this does. We just mint the referrer 10% of the tokens. Now is the point where we actually, once we have allocated points token to the referrer, we can go ahead and assign points to the referee, right? And if you remember, we had this referee points where we actually pass in the points that goes to the referee. So this is what this function does, where we actually end up at the last we give the referee some referee points. So now that we have assigned points done, we can go ahead and actually do the after swap and after add liquidity point function. Is there any question somebody has till this? Because it's a lot of information in 1 hour. I'm pretty sure somebody has questions.
I don't know, let's ask I don't know, someone has a question? I think, yeah, we have one question, Igor.
No, everything is clear. Thank you, sir.
Really?
Okay.
Okay.
I know
okay,
that we had some questions.
Wait. We have one question from the audience.
Yeah.
Yes, hi. I'm curious about does Uniswap v4 has some restriction about minimal liquidity, or it doesn't? And liquidity of pool after initialization can be 0 and can be for a long time.
I'm pretty sure that I would have to check, but I think it's okay to add liquidity, no liquidity. It's the same concept with wheat. Yeah, right? I think it's possible.
Yeah, you can create a 0 liquidity pool, yeah.
Yeah.
Okay, got it. Thanks.
Great.
Any other questions from the audience?
Any other question? Yeah.
Okay, no questions.
And
Okay.
one thing from me, I think we need to finalize in 5-10 minutes, if it's possible.
Oh, it's actually till 12:30. Oh, I was thinking we had time till 2:30. Oh.
I mean, we can if you have a time after this, because we just will have a fireside chat with Vitalik. You see, he joined the Zoom.
No way! Crazy.
Yeah.
Hey.
Hey, Vitalik.
Hello.
So, if you just have a bit more time, we can continue after the fireside chat.
Yeah, definitely. I'll try to. I feel incredibly grumpy in Vitalik's presence, but yeah. Let's actually go through this. Great. So I'll try to wrap this up by 2 o'clock. Is that what you're saying?
If you can just switch to the chat and then you can finalize after it, it would be amazing, or if it's possible for you.
Push to the chat. I didn't hear you. Sorry.
No, I mean just for now we will speak with Vitalik and then you will continue and finalize.
Okay, great. Definitely. Please. Yes.
Yeah, cool. Thanks, Vitalik, for joining. Guys, can you... Okay, yeah, I see that everything seems good. So yeah, I have a few questions actually for you. Thanks for joining. We have today like ETH Kyiv Impulse mini-hackathon. We are this mini-hackathon specifically around the Uniswap V4 hooks. And we have like a few devs there in Kyiv, offline. So my first, like, I have a few questions. After my questions, maybe someone from Kyiv would like to ask some questions. So my first question is, like, Web3 market right now is struggling with the use cases, and that's one of the reasons why we see the rise of meme coins. It's like, in my opinion. Can you say your top 3 use cases you really would like to see in the next couple of months?
I think for me, the use cases that are the most interesting are the ones that combine like some kind of financial element with some other kind of element that's not financial, that's like trying to provide value that's other than just seeing tokens going up, right? So, like, for example, right, I talk about prediction markets a lot, and like, I think a lot of people, even within crypto, underestimate like just how big an impact Polymarket has had, like even on the mainstream. Like, there's huge numbers of people, even the kinds of people who normally would say things like, you know, oh, crypto is terrible, there's no point in crypto, decentralization is useless. But you know, they forward screenshots of Polymarket to you know, like everywhere on Twitter, right? But to me, like that's only one example, right, of a category that could be larger. And the way that I think about it, about Polymarket, right, is I think of it as a betting site for the financial users. At the same time, it's a news website, a media site for the readers, right? Because for anyone who is not actually participating in the trading side, like, they're actually getting information, right? They're basically getting this view of, you know, like, what people think is going to happen in the future, how that's affected by different events. Is some event significant? Is it not significant? And so on, right? So I think, so one thing that interests me, right, is basically this idea of like, okay, what if we like take that kind of principle and we try to do a lot more different things than just than just prediction markets, right? Like, basically, trying to come up with something. I mean, it could be some new kind of social. It's you know, could be something else, but where like there is some kind of role for people to participate financially in some way. And like, basically, if you're participating on the financial side, then you are like making predictions of some kind. But then on the other side, it helps incentivize more high quality content. It helps curation of higher quality content. And so on and so forth, right? So like, actually, like, things that have the financial side and the social side, like, really talking to each other more. So that's one. Another thing I think is that I feel like non-financial use cases of blockchains are actually finally really starting to pick up, right? And so, like, I talk about Farcaster quite a bit, right? And I mean, Farcaster, it's a decentralized social. It doesn't do too much on the financial side, which I think is good. Like, I don't think everything should. But like, it does use the blockchain in actually the right way, right? Like, it uses blockchains in a way that basically to keep track of the information about people's accounts. And it combines that with another kind of off-chain data structure. And what you get is, like, you actually get a social network that actually has meaningful decentralization, right? Like, decentralization there, like, it's not just a buzzword, right? It's something where you can see it, you know, you can interact with it in Warpcast. If you decide Warpcast is bad, I don't want to use it anymore, then you can interact with it through a different client, you can make your own client, and all of the different clients actually can talk to each other, right? So it's like actually solving this kind of monopoly, lock-in problem, the walled garden issue that all of the social media things have, right? And like that's one example. I think at the same time, we've been seeing a lot more use of some of this like off-chain putting records on-chain types of applications. So I mean, we've had like things like popes for a long time. We have badges on Scroll, a pretty big ecosystem of them. We have more and more on-chain attestations. You have EAS, and you have open certs. Like and then all of the different combinations of that with zero knowledge proofs, right? So like actually starting to like put more information on chain in a way that's more cryptographically protected, in a way where it's digitized, but you also get a lot more trust that you know that the digital part of the system is not lying to you, right? Because all of the information that it gets put on chain, where like anyone can inspect and see it. So I think those things are valuable, right? And I think the reason why these things are starting to happen now is basically that we're like finally transaction fees are low enough that these things are usable, right? Like because transaction fees are low, so like all of these non-financial use cases become possible. If it costs like $3 for a transaction, like it did 2 years ago, these things would not be possible, right? So I think, those are a couple of starting points. Also, I think it's important to just continue to kind of value and respect the most simple use case of just like people using crypto for payments, right? It's something that really does, like continue to be an incredibly valuable service to just all kinds of people in the world who are in all kinds of difficult situations where nothing else works, right? And I keep, just heard, a story about someone from the Middle East just yesterday for whom the ability to just like put their wealth into crypto as because they just had to move countries is just a lifesaver for them, right? So I think it's a combination of some of those things, right? It's like I think the simplest stuff is valuable, and like the frontier to me, right, is these applications that really kind of sit on the edge between financial and non-financial, and like both provide value to people who wants to like predict things and participate on the financial side, but also like really provide like do good for everyone else by giving people access to like higher quality content or higher quality information.
Great, thank you for the answer. I think like okay. So a lot of people gathered today here to build on top of Uniswap V4, which should go live pretty soon. Actually, I think like this month, even maybe. What is your thoughts on the V4 version? Do you think it will bring a lot of new use cases into DeFi space? Because it's designed to be as flexible as possible for builders to add any custom logic to the Uniswap pools. I mean, to expect some kind of nice creative products on top of it.
I mean, I think for me, like the way that I see the token exchange space is that I don't see it as like features being added. I see it as like frictions being removed, right? So if you think like to me, what is the ideal world, right? The ideal world is like it's basically what we have with credit cards, right? With a credit card, you can pay in any currency, and then the person receiving receives in any currency, and then whatever the exchange is that needs to be done on the back end, it just happens on the back end, right? Now, with credit cards, of course, people take like 3%, and it's crazy expensive, and it's permissioned, and financial companies extracting a lot of money, right? And on the crypto layer, like all of that can be much cheaper and much more seamless and much more open for people. I think on the
but for example,
it's like
let me create. So for example, it allows you to protect from impermanent loss as one of these cases.
Right.
Also, but like it helps to protect you from MEV as well. And there are some bunch of use cases which could be also interested like in this kind of.
Yes, exactly. Yeah, and I think like all of those things are super valuable, right? It's I think it's this interesting situation, right, where these things are extremely valuable, but then the value that people are going to see like 2 or 4 years from now is that they will not think about exchange at all, right? Like basically, you know, within your wallet, you will be able to send ETH, and if the other person wants, you know, USDC, they will be able to get USDC, right? So it's and I think the opportunity is that level of just like zero friction of trade, at least between you know, popular and like medium scale ERC 20s will unlock is definitely going to be very very significant. It will enable even more people to do valuable things on top of Ethereum, but like at the same time, it's like over time, it will get more and more invisible. And over time, the attention will start shifting away from, you know, like actually interacting with the exchange layer itself to assume it works. And then you ask the question, well, what do you now build on top, right? So I think, I mean, right now, like really, putting in that extra effort to make sure that the exchange layer actually does have that really high level of efficiency. I think both from just like trading, MEV protection, liquidity, slippage perspective, and also from a user experience and convenience and speed perspective is definitely really valuable. And
Great, amazing. So yeah, also would like to talk about like the hot topic. It's as always, like fragmentation of liquidity problem between Ethereum L2s. I know that, for example, this year probably we will see the ZK cluster, which called Elastic Chain, I believe, which will introduce interoperability between ZK rollups, right? And also, I don't know when, but there is also Superchain cluster, which will do the same, but what about interoperability between clusters? And what is your like kind of prediction and thoughts on when we can feel like Ethereum as a united chain, right? Not like different chains. That's what you actually also wrote in your latest article, that we should feel like it's one united chain.
Yeah. So I think one of my views right now, right, is that I think it's easy to overestimate how much solving this problem requires, like solving complicated nerd problems, right? And underestimate the extent to which the main thing is just UX, right? Like, I think if we want Ethereum to look like a single chain, one very important thing that we all have to do is just like basically swapping between chains should not be like a separate thing that you go to for it's into a separate application. It should just be a feature of wallets, right? The wallet, you know, it contains the address would contain the name of the chain, and then your wallet would see if you're sending from one chain to a different chain, it would just automatically do that through a swap, right? So I think at the user experience level, we're actually not that far from having this experience where like L2 to L2 for many things can be maybe 2 seconds. And then obviously L1 to L2 for like regular users can be like 1 to 2 slots. And under the hood, I think the way that will work in the short and the medium term is basically everyone will work through like protocols similar to ERC 7683, like the intent-based protocols. And the reason why, right, is because like even if you look at optimism interoperability, at least from my understanding, the interoperability within the superchain, like the native interoperability, it has a latency of 20 minutes, right? And users don't want to wait 20 minutes, right? Now, the 20 minutes is still good. And the reason why it's good is because it makes it very efficient to be a liquidity provider. Because if you're a liquidity provider, then you just like do a trade on either chain. And if you have too many coins on one chain, you can just very quickly move them to Another chain, only 20 minutes, very low gas price, right? But from a user point of view, like the user would directly be using ERC-7683, right? The one place where this is not true is NFTs, right? Because with NFTs, like, with an NFT, there's only one copy of it, and so you can't have like a liquidity provider just give you another copy of an NFT. The only thing you can do is transfer it directly. So I think for that to happen, like we do need better native interop eventually. And I think that will just happen over time, right? So first within clusters, and then I think we'll start to see more Ethereum-wide things appear over the next 5 years.
Super. And okay, one also question, maybe proactive, maybe no. So when do you think we will see the first L2 in stage 2, and which one exactly it will be?
So one pedantic answer is that actually there's already 2 L2s that are in stage 2, right? So if you go to l2beat.com and you sort by stage, right, you see 2 of them. One of them is Fuel, and the other is D-Gate, which is like a decentralized exchange, right? Now, the reason why they're able to be stage 2 so quickly is because they were not EVM, right? They're trying to do very specific things that are much simpler than the EVM. And like, actually, I think doing that is often okay, right? I think it is much easier to unlock very high scalability for payments than it is for many other use cases. And so I think that's okay, right? And people should like even do that for payments, and then you can have payments be extremely cheap. For the EVM, the main challenge is that the EVM is complex and there's just a huge amount of code that you have to trust, right? And so I think, as I wrote in my post, right, there's basically 2 solutions to this. One solution is formal verification, and the other solution is the multi-provers. So the EVM rollups that I've talked to, they've been telling me that they want to get the stage 2 next year. I mean, will they actually get the stage 2 next year? Will they wait like 1 or 2 years after that? I think we'll see. But like, when I talk to the teams are feeling very ambitious and optimistic.
I see. Cool. And also one more question. Like I have 3 questions more, and then we can go to questions from the auditory. So will optimistic rollups eventually switch to the ZK rollups? And when it could happen, if you think so?
I think yes. And I think the key reason why is because any optimistic rollup, like it just has this extra cost that it inevitably has to pay, which is a native withdrawal has to take 1 week for the challenge period. And that just like really reduces liquidity. It also means withdrawing like NFTs is harder. So I think in the long term, I predict every rollup will be ZK rollup, but like, but I think even existing ZK rollups, they will have to completely change their stack, right? And the reason they will have to completely change their stack is I think users will demand L2s that commit to Ethereum every slot. And if you want to commit to Ethereum every slot, then one, you need to have a very low latency prover, like a prover that can prove an Ethereum block in like 5 seconds. It's okay if you need 500 GPUs. It just has to take 5 seconds, right? And those are almost exist, right? Like there are provers that can prove average Ethereum blocks in 15 seconds right now. So all we have to do is we have to get to worst case Ethereum blocks in 5 seconds. So I think it could happen quickly. And then the other thing is that you need on-chain proof aggregation, because like we're not going to pay 500,000 gas times 20 for 20 different L2s, because that would be like basically filling almost the entire block, right? So I think because of that, like basically every rollup, including optimistic and including even current ZK rollups, will have to change their stacks pretty radically over the next 5 to 10 years. But I'm optimistic that this will happen. That technology is being worked on already.
Great. Do you think all rollups will transform to the based rollups eventually? Or?
Not all. I think there's a valid niche for multiple kinds of rollups. So I think I think there will always be a niche for super fast rollups. So rollups that try to target gaming, like very low value consumer use cases, things where it's okay to have like somewhat more trust, but where people really want like very fast response time. Right. And so, you know, we're seeing like Mega ETH really try to target that niche. I mean, even Arbitrum, it's, 250 millisecond block times that's getting up there. So I think that like that niche will always exist, and that like those rollups will just inherently never be based. And then the second kind of rollup that will always exist is like a minimum rollup that just basically tries to be as secure and as trustable as possible. And I think for that, like you want as much simplicity as possible, and so it's better to just be based. Now, maybe there will be a category in the middle where rollups have their own decentralized sequencing. Maybe they won't. I don't know. I think a lot of that also depends on what happens to L1 in the next 5 years. But I do think that there are multiple categories.
Okay, yeah. Yeah, it makes sense. But if like we're speaking about the speed, yeah, so about block times and so on, like it also could be solved with pre-confirmations. As I understand, there is a way to do it like 100 milliseconds for the confirmation. Capricorn.
Okay. Yes, again. Okay, so right, so you mean like based pre-confirmations, right?
Yeah.
Because you have L2 pre-confirmations and then there's base pre-confirmations. Okay, so the challenge with based pre-confirmations is like, I think they can be good, right? But the problem is that like you cannot rely on 100% of proposers to be part of the pre-confirmation scheme, right? Like all of these pre-confirmation schemes, like they're voluntary, they're things that proposers participate in because they want to get more revenue. And like you're always going to have a few stakers that are just too lazy to implement it. And so what you might get is you might get a system where, let's say, 95% of the time, you get pre-confirmations every 200 milliseconds, and then 5% of the time you have to wait 12 seconds, right? And I think for some use cases, that's fine. Like, I think for payments, that's fine, right? Like, I think, when you pay with a credit card, right? It's like, it does happen pretty often that, the wheel keeps spinning and there's like some delay and you have to wait for like 15 seconds. And like, that's okay, but we don't want it to happen too often. So I think for some use cases, that's fine. And like, especially if we can reduce the L1 select time, like if we can say 95% of the time, 250 milliseconds, 5% of the time, 4 seconds, then I think okay, right? But like I think even there will be some use cases, like especially gaming. Like I think for gaming, you do want something that's more specialized.
Yeah, okay. And last question from me. So when do you think we will be able to see faster blocks on Ethereum L1? I think I know that there are a lot of discussions in the community and concerns regarding the bandwidth increase. For example, if we drop the block time from 12 to 8 seconds. But I think like eventually it's important for the UX. So yeah, what do you think about this?
Yes. Yeah, this is an important question. So I think it's important to separate bandwidth and latency, right? So for example, so basically reducing the slot time and increasing the gas limit, right? Because if we decrease the slot time to 4 seconds, but then we also decrease the gas limit to 10 million, and we decrease the blob target to 1, right? Then the bandwidth will still be the same, right? But the problem is the latency. Like there's people who are already in running nodes in regions that are, like far away from, like New York and London and the big centers. And currently they sometimes have trouble getting like publishing blocks that get accepted. And so those problems might become worse. I do think that Ethereum's peer-to-peer network right now is very far away from optimal, and I think there's a lot of value in like actually doing the research and like really optimizing every single layer of the Ethereum P2P. And maybe if we do that, we actually can get down to 8 seconds or even 4 seconds. But I think it's really important to do this safely, right? And to like basically take care to preserve our staking decentralization.
So do you think we can expect some changes in the block times in Pectra, or like at least in part 2? I understand that in like Q1 2025, it's I think it's not realistic, but maybe in the end of the year.
Yeah. I think Pectra is unlikely just because there are so many things. But I think 2026 is very possible. But for it to happen in 2026, like it needs to have a champion and it needs to have people really putting in high quality research, right? So, and I think if you are someone in the ecosystem who would really benefit from faster swap times, then like you, I think, have the opportunity to go and like make a group, contact some of the other people you think would benefit, and like really start pushing for making the proposal much more concrete and like doing all of the and then like reach out to the core developers, right? Like reach out to Geth, Netherminds, Nimbus, Basu, Teku, and like basically ask them, like what kind of evidence would they need, and like actually do the work to start gathering that.
Amazing. I think we have one question from Manu. All right, you can go ahead.
Hey, Vitalik. Hey. Yeah, today's context of like faster block times and the Uniswap V4 coming out, I wanted to ask you about the hottest thing right now, Unichain, because I remember like you tweeting a bit earlier about maybe we don't need Unichain, like app chains like this. Uniswap isn't like supposed to be like a chain itself, but I want to ask, like, has your opinion changed on it? Now that have you maybe read the white paper? Yeah, I just want to know a bit your opinion on what Unichain.
Yes. I mean, I definitely think it's really interesting. I mean, I think it's good to see the level of quality of all of the exchange offerings on Ethereum just continuing to increase. So I think it could definitely be valuable for just making exchanging on between different L2s much more seamless. So I definitely wish the project the best.
Great, amazing.
Yeah, and let's also have 2 or 3 maximum questions from the guys from Kyiv, from the office. Like anyone?
Hello.
Yeah. Hello.
Can you hear me? Well,
Yes.
great. We're so happy to see you with us today, and I think we have some questions from the audience, and let's start.
Yeah, hi Vitalik. This is Kirill Vorokhovsky from National University Kyiv Academy, blockchain professor here. I have a question. What is your assumptions about decentralized AI or decentralized machine learning, which is on the hype now?
Decentralized AI. Yeah, I mean, so I think we've recently saw that announcement, right? And I forget exactly who was involved, but that like there actually was a distributed AI training run of a model that was done recently, right? Which I think is interesting, right? I think I mean, it definitely is valuable to just continue to make sure that the open models are like don't fall too far behind the frontier of what the commercial ones are doing. I think for a lot of these other AI use cases, like it really just it depends a lot on what the underlying goal is, right? Because I think sometimes, like basically, like what you're trying to accomplish with the decentralization, right? So sometimes the goal is to like get some to just be able to like bring data and computing power from different users together. Sometimes you want to like give your users guarantees about users being able to control their own data, certain kinds of safety, certain kinds of privacy. So it's like I think I always want to, like to start from asking the question of what the goal is. And then once you have the goal, then it's like from there it depends, like what kind of decentralization do you want? Do you want any kind of cryptography? Is the thing you want just having AI models running on people's devices? Is it something else? And then if you start with the requirements, you can figure out what the right approach is.
Thank you. Guys, any other questions?
Any questions from the audience? Raise your hand if you have any questions.
Okay, so I think if no, then we can wrap up the discussion. Yeah, so as the last thing, I would like to ask you, what can you recommend to the people who are newbie, let's say, to the blockchain and Web3 space and Ethereum in general? Yeah, so like any like hints or I don't know advices for them?
I think the best way to learn often is to just build things, right? So, I mean, even just takes anything in whatever category that interests you, right? Like actually try to build a wallet or build a decentralized Twitter or build, an exchange between layer twos. And like just give yourself the task and just force yourself to learn what you need to learn in order to get it done. And I think that by itself is already a really valuable way to learn a lot of important concepts. I mean, it's like that is the way that I learn about ZK snarks, and so I think it's very effective, right? And so that I think is if you are a developer, if you are like someone doing like community organizing, for example, which I also think is definitely valuable, then like the most valuable position, right, is to both actually understand the technology and like what it can do and what it and what it can't do, and and also like I think be brave in trying to really understand more of those things yourself, and at the same time like actually understanding some particular group of people, right, which can include users, it can include developers. And like if you would do a good job of really having both sides, I think you can be very effective.
Sounds amazing. Vitalik, thank you so much for joining. I'm pretty happy to have you here. And yeah, I mean, feel free to join any mini hackathon you want. So we will have them most likely monthly kind of things in Kyiv. So yeah, thank you so much for joining. Appreciate it.
Дуже дякую тобі. Бажаю вам всім щасливого дня.
Дуже дякую тобі. Клас.
Okay.
Супер. Bye. Yeah, and I think I think we can continue with the workshop and finalize it. Yeah, sorry for this kind of things, but I mean.
Yo, this is crazy. You should have told me that he was gonna pop in. I was like, what? Vitalik?
It was a bit like so like there was problems with like there were some problems, but we fixed them. Everything is good now.
It's all good. It's all good. Like as well.
Yeah.
Shocked. Yeah. Appreciate it.
Sure.
Okay. Where were we? Let me share my screen again. Okay. So we have how much time do we have?
I think we can go ahead and finish whatever time you need. But I mean, let's do maybe. Is it enough for you 30 minutes or something like this?
Yeah, I can try to wrap up with that. Okay.
Yeah, cool.
Great. I think we're almost to the end also. Okay, so I just want to do a quick recap of what we did till now. So, okay, so we're doing the points hook. So we give people points token whenever they swap in the ETH to token pool. When somebody adds liquidity, we give them some points token, and when somebody refers them, again, we give them a points token. So till now, we wrote like a small after swap, yet to be filled with the main code logic. But right now, we have an assign points function that can actually assign people points token if you pass in the hook data and the referee points. And we have a helper function called hook data, get hook data, that can get you the encoded bytes of the referer and the referee. We did hooks.permission to establish all the different hooks that we'll be using. Okay, great. So now we just really, all we have to do is the after swap main logic and after add liquidity main logic. So let's just do that and we'll be almost done. Yeah. Great. So what we want to do in after swap is there are a few conditions that we need to check. So the ultimate goal in after swap is we want to give people points token when they swap in swap ETH for a token. For this, there are a few conditions that we need to check. We want to check that the pool that this hook is attached to is a pool that has Ethereum ETH as one of the tokens, right? So that's one of the checks, because the goal is that we want to give them points token whenever they swap in this ETH to token pool. So if there is no ETH, there's no point in doing this. So that's one of the conditions that we need to check. And one of the other conditions that we need to check for is we want to see if the person swapping is swapping ETH for token. So it means that we want to incentivize people buying the token, right? So in case that they're buying the token by giving out ETH to the pool, then we're good to give them the points token as a reward. But if they're actually selling the token, then we don't want to reward them with points token, right? So these are two checks that we need to do, and the way we do that is by going to so we're going to use a couple of functions that comes with the balance delta and internal base hook contract. So this is it. Okay, great. So as I said, the first check that we do is we want to check if the token 0 that we have in the pool is ETH. So in the case where the token 0 in the pool is not ETH, we want to just like return or like get back from this hook, because we only want to swap or incentivize people to have points token if it's an ETH pool, if they're actually giving out ETH for tokens pool. So the way we do this is by actually using the key. And if you remember, we have a pool key that has all the data about the pool that we're actually currently swapping in, right? If we check in the pool key, we have a currency 0, and the currency 0 denotes the first token in the pool. So so if you have a pool of any token with ETH, the first token or the first currency is going to be ETH, right? So what we're doing is we're checking if the currency 0 or token 0 is not an 0 address. Because when you have a pool with ETH, the currency 0 is denoted by 0 address, because it's a native currency, right? And so that's what we're doing here. Is we're checking if it's not ETH, if the token 0 is not ETH, we just return out of this function, and then the rest of the swap just happens accordingly, and we don't do any of the points rewarding mechanism that we planned. And the second condition is we want to mint points token to these people only if they're actually swapping in ETH for token. So we want to only incentivize cases where they're actually buying the token from the pool, right? If they're selling the token, we don't want to do that. So that's what we're doing. So again, then we use these parameters, swap params, from pool.manager.soul. So what this particular variable does is it checks what kind of swap this is. It basically checks the direction of the swap. So 0 for 1, if this variable is true, it means that we're swapping token 0 or currency 0 for token 1 or currency 1, right? So in this case, we know that, like we said before, we know that if there is an ETH in this pool, it's always going to be token 1 or token 0, right? The first token. So if the person is actually giving ETH and taking token from the pool, swapping ETH for token, then it is in fact going to be a 0 for 1 swap, right? So we want to check if this swap is actually a 0 for 1, and if it is, then we want to continue. But if it's not a 0 for 1 swap, which means that it's actually selling the token from the pool, then we want to discontinue. So that's what we're doing it. So we're checking if it's not a 0 for 1 swap, if he's actually selling token to get back ETH, then we just like don't assign him the points token, right? We don't reward him, but we don't incentivize it. So that's what we're doing. Great. Now that the checks are over, we can actually go ahead and calculate how much tokens we want to give this person, how much points token we want to give this person, right? So to do this, we go to swap params, and we take in amount specified by the user. So if you remember, we have two types of swap, exact token 0 for token 1 swap, and we have exact token 1 for token 0 swap. So in the case that it's an exact token 0 for token 1 swap, it means that the amount specified in this variable is going to be negative. How so? So if you remember, all the token movements across this V4 is denoted by delta changes from the perspective of a user. So if the token is leaving a user's wallet, it's going to be negative. If the token is going to user's wallet, it's going to be positive. So if we check here, if the swap params.amount specified of token 0 is less than 0, if it is, it means that the token is actually an exact 0 for 1 swap, which means that we could actually just take the negative of this amount specified, and then we can just use that as the exact amount of ETH that is being spent. And if it's not, if it's actually an exact output for input swap, which means that we know how much token 1 we're getting, but we don't know how much token 0 is going into the swap, then we use delta. So remember, we had something called the balance delta, and the balance delta knows exactly the exact amount of value of token 0 and token 1 going out of the swap, right? And then we just like this is that special parameter that's only available in after swap. So this parameter exactly knows how much token 0 is coming in the cases where the user hasn't specified an amount 0. So we use this in this particular case. If I'm being if you want to even simplify this, you can actually just do this, where you just like do this, because in the end case, delta of amount 0 is always going to be the token 0 amount. Okay. So now what we want to do is we finally get to the point where we actually assign them the points token. And if you remember, if we plan to reward user with 20% of the ETH that they're spending, that they plan to spend. So we have already got the exact amount of ETH that this person is spending, and we just calculate 20% by dividing it by 5, right? So now we have the exact points that we want to give this person to. And then ultimately that's basically it. We just assign points. We just call this function that we wrote earlier to assign points token to this person, right? We pass in the hook data, which contains the referrer and the referee, and we pass in the points for swap that we just calculated right now, and the function will just automatically assign them the points token that we have. And to exit out of the function, if you want to denote that this function ran successfully, we have a couple of return parameters. So the first parameter, bytes4, is actually used to denote the selector of this particular after swap. That means that if this function ran successfully, we're letting Uniswap know that this function ran successfully by actually passing in the selector of this function, the after swap function that we're currently in, right? And when we pass in, it means the execution ran successfully, and we can just move forward. So that's how the after swap code logic works. And now we just have like one more function that then we're done. Well, let's take a look at add liquidity, right? So in this case, we don't have to worry about the user swapping token by selling the token, because they're going to add like both of the tokens, right? Anyways, so we don't have to worry about that case. But we still have to worry about the case where the pool attached to this particular hook is actually a pool which has ETH in it. So we're gonna take the same code which checks if the pool has ETH in it, if the pool, one of the tokens in this particular pool is ETH, and if it isn't, we just like return early, right? We just discontinue the execution. So that's what we do. So this is the only check that we need, and then we're good to assign them the tokens. So to assign them the tokens, we basically again calculate how much delta of amount 0 we have. If you remember, delta is the exact amount of token 0 of tokens that's passing, and delta dot amount 0 is the exact amount of token 0 that we have while adding liquidity, right? And the points for adding liquidity is in the case of adding liquidity, we just assign them the equal points equal to how much ETH they're planning to spend, right? And we have points for adding liquidity. Once we get that, we just again call the assign function that basically assigns them the exact amount of tokens, that points token that we need to give them. So now we're almost actually ready to be done with this. The hook contract is actually done. We have a function that rewards user for swapping in, and we have a function that rewards user to add liquidity. The only thing that we need to do is actually just do a test run of this. So I'll just do a fast execution of the test contract. So I'll make a test script for this. I'll delete the counter test. I'll quickly explain the test script. Point, hook, test itself. So, okay. So I'm not sure if you're familiar with like Forge testing, foundry testing, but I'll quickly go through like what exactly we want to test. So we want to test things we want to test is a user is getting token, points token, when they swap ETH for token, token. And the next thing we want to test is that user is getting points token when they add liquidity. And the next thing, the final thing that we need to test is we want to check if the user is getting points when they refer somebody. So these are all the old things that we just wrote, right? Great. Now, if you're familiar with like Forge testing, you'll have a function setup that runs before like each test function, and it basically tests like deploys a Uniswap pool with the parameters that we specify. So Uniswap v4 also has a deploy as contract that we can use to quickly deploy a token or pool. So if you go to this, we'll see parameters about the token deployment. So this is a code that used to deploy the pool, and you'll see that we have parameters like swap router. We have the key for the pool. We have the pool manager, all deployed it using the deploys.sol. So now what we want to do is we use the deploys.sol from Uniswap to just test this thing. So deploy fresh manager and router is again what it stands for. It just deploys routers and managers for Uniswap v4. And then we try to make a test token, the token contract that we just that's planned to be swapped with ETH in a pool. So we deploy that, and then we just make a wrap. So currency is like a library that we use to just call certain functions. It's just a library that helps us do a bunch of things quickly. But the main thing is we mint this contract a bunch of token worth 1,000 tokens, and then we mint like a random address, check the referrer, but we mint ourselves a bunch of tokens. And then we want to enable, so if you remember, we want a hook contract address to be having a certain bits. So for that, from the hooks library that comes from Uniswap v4 core, it actually has an easy way to do this. So you'll get the exact address with the bits flipped for the hooks that we plan to add. So if you remember, we're using add liquidity and we're using after swap, right? And if you pass on this, we'll get an address that has the exact bits flipped for it to be valid with the hooks that we plan to do with the hook contract. So again, there's another cheat code in Foundry Forge test that's called deploy code 2, which allows us to just deploy the code to a random address that we plan to do, or like a specific address that we have to deploy to. So in real world use cases, we'll actually be mining for this particular address and then actually deploying to that. But since we're just doing the force testing, we can just use this function to do the same thing. Then we actually go ahead and deploy a points hook, and then we get the address back of the hook. What we're doing here is we're approving swap routers, and we're approving the modify router that's used to swap tokens and that's used to modify liquidity, add liquidity to the pool, and we're approving them the tokens, the token. And then we go ahead and initialize pool. If you remember, we have certain parameters too that actually knows that it's a pool, right? We have the ETH currency, that's the token 0. We have the token currency, that's token 1. Then we have a hook contract, which is the address of the hook, points hook. Then we have the swap fees, we're just setting it to 3,000 for now. We have the square root price, it's set to 1:1. And this is, this just specifies that initially when the token is deployed, token pool ETH to token pool is deployed, the initial price is going to be 1:1, which means that one token is going to be equal to 1 ETH. So that's what this is doing. Then moving on to the actual testing functions. So we have two main functions that we want to test. So we want to test adding liquidity and swapping it. So if you take a look at this, what we're doing here basically is like we get a hook data, the same function that we use to get back hook data for a particular referrer and referee from this particular function. And then we just get the hook data back. And once we have this, this is the bytes format of the referrer and the referee. Once we have this, we check how much balance we have initially before we actually go ahead and swap, do some swapping and do some liquidity modification. This will be used to actually assert if we actually get the points token back once we do the swap or once we add liquidity, right? And we get the price ranges that we want to add liquidity to. So this is a bit of a topic. So if you're familiar with the Uniswap v3, it's ticks. It's exactly how the ticks work in v4 too. So this denotes prices, the price range that we want to add liquidity to. So the lower tick is minus 60 and the upper tick is 60. So this is where we plan to add liquidity to the pool, right? And once we get the square root price of that, so this is a special number called Q64, which is used to denote the price at which we want to supply the liquidity to. So once we have this square root upper and the square root lower price, we just calculate how much amounts we want to do amount of token 0 and token 1 we want to add to the pool. So the V4 test contracts has a liquidity amounts contract that can be used to like calculate exactly how much token 0 and how much of token 1 we need to add for a particular price range. And that's what this does. So once we get the exact amount of tokens, token 0 and token 1 we need to add to a particular price range, we just go ahead and add it. That's it. So we have the modify liquidity router, and we call the function called modify liquidity, and we pass in the amount of ETH here. So this is the amount 0 delta, and we pass in the key, we pass in the modify liquidity parameters, which includes the ticks, the lower ticks, and the upper ticks. We pass in how much liquidity we want to modify. So in this case, we're just doing like 1 ether, and then we just pass in the salt. So, and we also have to give it the hook data. So in this case, we don't have a referrer, but we have a referee, which is the contract itself, the person doing the testing itself. Once you pass in all these parameters, we get a liquidity modification, and then we again check the balance of the points token that we have. So if you remember, once we add liquidity, we are supposed to get like a particular amount of points token as a reward back, right? So that's what we do with the, that's what we're checking here. So now we want to check that we actually got back some points token for adding the liquidity. So that's what we're doing here. Yeah, we check the point balance after adding liquidity, and we check the point balance before we added liquidity. And turns out that when you add liquidity in a 1:1 ratio at this particular price range, so this is a pre-calculated number. So this is the exact number for adding the liquidity at this particular lower tick and this particular upper tick, and for the amount of tokens that we plan to add, right? And we just check, we just assert if we actually did in fact get that particular number of tokens back. And if we do, we're good. The test passed. And then we have the same thing, but for swapping, where we check if the swap, actually doing a swap will return us back some points token. So again, we do a sample swap where we pass in 0.001 ether, the key, the pool to which we want to add liquidity to. We pass in the swap params. We check that 0.41, we're actually buying the token by supplying ETH. We specify the amount. And yeah, and we pass in the hook data, where again the referrer is 0, but the referee is the person doing the testing. So then we check again the same logic with the adding liquidity. We check how much balance do we have after swapping, and we subtract the balance after swapping with the balance that we had before swapping of the points token, of the rewards token, and we calculate how much we're supposed to get back if we did this particular swap. And we check if that is equal to the actual value that we're supposed to get. And if this passes, it means that we are successful. So I don't want to go to the referral again, but it's basically the same thing. But instead of like having an address 0 as the referrer, we just do a random address to check if the address passes. And then we again do the same thing where we modify the liquidity, and then we do a swap. And then we check again the balance before the swap, and the balance before after the swap matches the exact points token that we're supposed to get. So that's what this function is. Basically like a clone modified a little bit to check for the referrer case. But if we were to run this, ultimately we should pass the test, but let's try that. Let's see if the code works by running forge build, and if it has any errors. Okay, there are a couple of things. So line number 109, spelling mistakes. Supposed to be capital S. Hopefully it works now. Okay, so I think it's just a couple of warnings. That's okay. So now we can again go ahead and run the test contract that we just wrote. So for its test, okay, we'll do forge test. And if this passes, it means that people are getting tokens and people are getting points token for swapping and like adding liquidity. So that's like a gist. I do understand like they didn't get all of things because it's like a little time for covering everything from Uniswap v4 to hooks to using after liquidity, add liquidity, and after swap. But this is generally the gist of how like making a hook works. You just make a hook, you add all the hooks that you want to attach to your hook, and then you deploy the pool, and then the pool just works with the custom logic that you just wrote. So that's basically it. That's actually it. I hope you had got at least like a general gist of how to make a hook contract. And if you have any questions, I would love to take them. But yeah, that's it.
I think you did amazing job. Thank you so much. I mean, in terms of like onboarding people to Uniswap before, it was super interesting, even for me. And I guess like for everyone who was listening and learning how to build on Uniswap before. So Igor or someone from the office, do we have any questions?
Yeah,
people?
we're here. Guys, do we have some questions here? Everyone is like so confused with everything that's happening. So yeah, and they already started to build. So unfortunately, no. But anyway, thank you so much. We have here. Yeah, we do have 2 questions.
Oh, nice.
You haven't any? No questions, but only thank you and huge hugs from Ukraine. But anyway, we have one more.
Yes. Again, thank you for your lecture. Yes, very interesting. And I will review our record. Yes, of your lecture. I questions about first.
I think we have trouble with connection.
Okay. 1, 2, 3. Can you hear me? Okay.
Yes, I can. Yes, I can.
So I check code of pool manager and I confused that when I add liquidity, yes, and execute function add liquidity in pool, modify liquidity. Sorry.
Yeah.
Yes. Give me a moment. I want to recheck. When we mint LP tokens for sender of liquidity. Yes.
Yeah. Yeah, it happens during the main actual swap. So that part is managed by the Uniswap v4 core. So we're not concerned with that, but we're just only concerned with the points token that we supposed to give them as an incentive. So if you're specifically asking about points token, like I can show you exactly where we meant. So if you remember, we wrote like a assign points function that's supposed to give them the points when they do a swap or when they modify liquidity. So this is the exact function that where we mint them the points token.
Mm-hmm.
So yeah, this is where we do the points.
Oh, okay.
But if you're asking, yeah.
Yeah, I got it. Thank you. And I don't have any questions. Yes, thank you.
Okay, amazing. Thank you.
Thank you so much. Thank you for being with
Oh,
us.
maybe sorry, I have a question. Maybe you can tell more about the Atrium University and the new cohorts which you will have, so I believe soon.
Yeah, definitely. So if you're, you might have heard about the Uniswap Hook Incubator. So at Atrium, what we do is we run this program called UHI, Uniswap Hook Incubator, and Rostislav was one of the members of the first cohort that we did. And we basically go in depth into how to build the V4 hook. So the points hook that we just built is actually one of the chapters that we do in the series of workshops. This is a series of about like 10 workshops followed by a hackathon just for hooks. So we talk about different kinds of hooks. We go further into different kinds of hooks. Like there are a bunch of hooks that we didn't talk about at all. For example, like no up hooks. We basically didn't talk about basically any of the rest hooks, right? So in this workshop series, we basically go into like all the different kinds of hooks, all the different possibilities with hooks. We have some sessions, some workshops where we build hooks live. We have some conceptual lessons. We have office hours with SaucePoint from Uniswap. So in case you have any questions about the hooks or V4 or anything you're building, you can ask it directly to him. And the workshops are led by Hardik. He's a great guy. He's also leading LearnWeb3.io, and he's the lead instructor for the program. And yeah, the first 6 weeks, it's just workshops on different kinds of hooks. I can also show you the exact content that we teach in the website. If you go to atrium.academy/Uniswap, you'll be able to see the exact things that we teach. Yeah, so liquidity operations, dynamic fees, no hooks, and that's what we basically teach. And at the end of the workshop series, we also do a 2-week capstone phase where you're incentivized to build hook products using V4, and we actually have bounties for that. We also partner with like other protocols like Brevis, Chainlink, or EigenLayer who sponsor prizes for this. So if you're interested, yeah, totally do please apply. Like we have our applications open for the cohort that starts 23rd of January 2025.
So the next one will be from in January, right? Okay.
Yes, that's correct, and the applications are open right now. So the one that has already started right now, another one. So the next one is going to be on January.
Maybe you have some insights from like when before actually will be launched.
You are asking me. I have no idea when Unique will be launched. I'm curious to know that.
Okay. Okay, sounds amazing.
All right, sounds good.
Yeah, thank you for being a part of our small mini hackathon, and I mean that's amazing. Thank you for the workshop. It was cool.
Thank you.
Yeah. Again, sorry for this kind of things in the middle of the workshop.
Are you kidding me? No, I
But,
love that. I'm telling you, I appreciate that.
Okay. Nice. Okay, so I
Yeah.
think we are done here. So thank you so much.
Thank you so much. Have a good day. Have a good day at the mini
Yeah, and the
hackathon.
voice
Wish
from
you all the best.
Ukraine sending you huge love and hugs. Thank you so
Hey.
much.
Thank you so much.
Yeah,
Heart from
bye-bye.
India. Bye-bye.
Bye.
Bye.
Да, тепер я скажу останнє і піду. Також дивіться, в нас, ну, типу, зараз там, я думаю, ви вже поділились по командах, вже там майже ніхто мене не слухає, всі там займаються своїми речами. Типу, ну це окей. Я скажу єдине, що, ну, ви вже всі так працюєте над такими своїми проектами. Буду дуже радий побачити там якийсь результат в кінці дня. Чекаю на ваші сабмішени, проекти. Ігор опише там, як сабмітити проект. Ігор, прохання, давай зробимо це максимально просто. Типу, якщо є бажання в когось, та буде бажання в кінці, можна зробити такі міні-сесії там пітчу. Тобто, наприклад, ви можете зробити там міні-презентацію, аля там 2-3 слайди про те, що ви зробили, чому, типу, і презентувати, якщо у вас буде бажання. Але це не обов'язково. Це, звісно, за бажанням, якщо у вас буде час, там і так далі. Ось, там також, мені здається, вже починається обід, або вже почався, але там, якщо що, до Юлі. Ну і все. Гарно провести час і давайте білдіть. Дуже хочу подивитись на результат.
Через 5 хвилин буде вже анонс в Діскорді, там, де я розпишу про те, як можна зробити сабміт свого проєкту та додати свою команду на платформі DoraHacks, де і буде проходити сабмішн проєктів.
Угу.
Друзі, ми всіх запрошуємо на групову фотографію, така невеличка розминочка. Прошу, будь ласка, підходьте. Потім у нас о 13-й буде обід, він в форматі лаунчбоксу, тобто коли ви захочете, вам буде зручно, підходьте обідати. Зараз у нас, Ростислав, не відключайся, зробимо групову фото. Всі, хто тут є, підходьте, бо не змушуйте вагітну жінку підходити до вас. Тому підходьте, будь ласка.
Так, це один раз. Дуже вам дякую за те, що підходите. Бачу, що підходять. Ну, розумієте, да? Це нам, типу, потрібно, бо зараз, ну, все одно, типу, це нам потрібні ці фотографії, і щоб просто, ну, щоб зрозуміти, скільки людей було і так далі. Ну, але, звісно, найважливіше це все ж таки проекти, які будуть засубмічити в самому кінці дня, тому... Да, я думаю, що трансляцію вже можна вимкнути, якщо що.